What if I told you that everything you see, the stars, the planets, even you and me, comes from a universe that is 13.8 billion years old? That number is just a wild guess. It's one of the most carefully calculated and confirmed facts in all of modern science. But how on earth do scientists measure something that's older than the Earth itself? Older than our sun, older than time as we've ever known it. To find the answer, we have to go back, way back. All the way to the very beginning. Picture this, 13.8 billion years ago. There was no before. The universe didn't explode into some pre-existing space. No, it was the moment that space itself was born. In a fraction of a second, an instant so small, it's almost impossible to imagine, the entire universe expanded from a point smaller than an atom into a rapidly growing cosmos filled with pure, searing energy. We call this moment the Big Bang. Back then, there were no stars. There were no galaxies. There weren't even atoms. It was a universe of just heat, light, and relentless expansion. A cosmic fireball, growing at an incredible rate. As the universe continued to expand, it began to cool down. This cooling allowed some of that raw energy to transform into matter, creating the very first subatomic particles. Over time, these particles came together to form the simplest elements, hydrogen and helium. The universe was still a vast, dark place, but a new force was starting to take charge, gravity. Patiently, relentlessly, gravity began to pull these clouds of hydrogen and helium together. After hundreds of millions of years of this cosmic gathering, the pressure and heat at the core of these massive clouds became so intense that something incredible happened. The first stars ignited, flooding the young universe with light for the very first time. These ancient stars lived their lives, burned through their fuel, and then died in spectacular explosions called supernovae. These explosions were cosmic factories, forging heavier elements like the carbon in your DNA, the oxygen you breathe, and the iron in your blood. Every single atom that makes up your body was created inside one of these ancient, long-dead stars. You are, quite literally, made of stardust. You are the universe observing itself. So, how do scientists actually arrive at that specific number, 13.8 billion years? It's not just one measurement. It's like a detective story with three main clues that all point to the same conclusion. The first clue is the expansion of the universe itself. The second is a faint, ancient light that fills the entire cosmos, called the cosmic microwave background. And the third clue comes from studying the oldest objects we can find, ancient stars. When you put all three pieces of this cosmic puzzle together, they tell one single, consistent story. Let's start with the expanding universe. Back in the 1920s, an astronomer named Edwin Hubble was looking at distant galaxies through his telescope, and he noticed something truly mind-boggling. Almost all of them were moving away from us, but that wasn't all. He discovered a clear pattern. The farther away a galaxy was, the faster it was moving away. This is the hallmark of a universal expansion. Imagine drawing dots on the surface of a balloon. As you inflate the balloon, every dot moves away from every other dot. From the perspective of any single dot, it looks like everything else is rushing away from it. Our universe works the same way. So, if we know the universe is expanding now, we can run the clock backward. By measuring the current rate of expansion, scientists can calculate the exact moment in the past when everything must have been packed together into a single point. And when they do that calculation, they land right on that magic number, 13.8 billion years ago. Now for our second clue, the oldest light in the universe. For about 380,000 years after the Big Bang, the universe was so hot and dense that it was like a thick, opaque fog. Light couldn't travel freely. It was constantly bouncing off particles. But as the universe expanded and cooled, it finally reached a point where it became transparent. For the first time, light could travel unimpeded across the cosmos. And that ancient light, that first light, is still traveling today. We call it the cosmic microwave background, or CMB. It's essentially a baby picture of the universe, frozen in time. It's everywhere, in every direction you look. Specialized NASA satellites like COBE, WMAP, and most recently, the Planck satellite, have measured this faint glow with incredible precision. The tiny temperature variations in this ancient light hold the secrets to the universe's age, density, and composition, and the data from these maps confirms, with astonishing accuracy, that the universe is indeed 13.8 billion years old. Our final piece of evidence is perhaps the most straightforward, looking for the oldest things we can find. Astronomers can study the life cycles of stars to determine their age. They look for stars that are made almost entirely of hydrogen and helium, the original elements from the Big Bang. These are the first-generation stars. Within our own Milky Way galaxy, we have found stars that are incredibly old. Some of them have been dated to be over 13 billion years old. Logically, the universe has to be at least as old as the oldest things within it. These ancient stars couldn't exist if the universe itself wasn't older. So, whether you run the clock back on cosmic expansion, analyze the baby picture of the universe, or date its oldest inhabitants, every method points to the same inescapable conclusion: 13.8 billion years. So take a moment to really think about what this means for us. Modern humans have been around for maybe 300,000 years. The entire history of our civilization is just a few thousand years old. The universe existed for 13,800 million years before we ever showed up. We exist in just a tiny, fleeting moment of cosmic time, and yet, in this brief instant, we, a collection of stardust on a small planet orbiting an average star, have managed to look out into the vastness and figure out how old it all is. We are the universe's way of thinking. We are a part of this grand cosmic story, trying to understand our own origin. Every star you see in the night sky is a message from the past, its light having traveled for years, or even thousands of years, to reach your eyes. Every distant galaxy we photograph with our telescopes is a time machine, showing us what the universe was like millions or billions of years ago. When you look up at the night sky, you're not just seeing empty space dotted with lights. You are looking across time. You're seeing 13.8 billion years of cosmic history laid out before you. And the most exciting part, the story ain't over. It's still unfolding, and we're here to witness it. Thanks so much for watching. If you're as fascinated by the cosmos as I am, don't forget to like this video and subscribe for more journeys into the universe. See you next time.